Hello, this is Mrs. Ward, and today we're going to go over the 5, 6, 5, 8 practice tests. So we're going to begin by rewriting using radical notation. So the first one, I have 6 raised to 4/3 power. Remember to rewrite that as a radical. This is my index, so 3 is my index, 6 is my radicand, and I'm raising it to the 4th power. I can look here and for my perfect cubes and realize that there is no factors of 6 that are a perfect cube. So I cannot simplify this, but I can simplify the fact that this index is less than the power. So 4 will go into, or 3 will go into 4 one time, so I can bring 1 6 outside. And then I'll have 1 left over, which means 1 6 stays inside. And that will be my final answer, 6 times the cube root of 6. Looking at the next one, I have negative 125 raised to the 5/3 power. Again, writing it in radical form. 3 is my index, negative 125 is my radicand, and I'm raising this all to the 5th power. Checking for my perfect cubes, I see that 125 is there, and that is 5, but since it's negative 125, this will be negative 5 raised to the 5th power, and when I do that, I end up with negative 3,125. Looking at number 3, I have 7 to the 3/2 power, so I am going to get this guy out of the way for a second. Writing it as a radical, I'm going to have the index is 2, 7 is a radicand, and I'm raising it to the 3rd power. When I look at my perfect squares, 7 is not on that list, but I can simplify the 3/2. So 2 will go into 3 one time, so I can pull 1 7 out. I will have 1 7 left over, so my final answer is going to be 7 times the square root of 7. And you don't have to write that 2 because it's understood to be a 2 if nothing's written. Okay, this one, rewrite using rational exponent notation. So I'm going to take, this is understood to be a 2, so this will be 11 to the 1/2 power. And I cannot simplify that at all. The next one, I have 5 as my radicand, and it's raised to the 4/3 power. Remember, this index is the denominator. The last one I have is I have 9 raised to 12/3 power, which will just be 9 to the 4th. And if you ended up doing that in a calculator, you end up getting 6,561. Okay, moving on to the next. Now I want to simplify. I have these written in rational exponents. So in order to simplify, I'm raising a power to a power. So using properties of exponents, that means I would multiply. So this would be x. And I'm going to take 3/8 times 5 6, because that's what I do when I raise a power to a power. When I multiply those, I end up with x to the 5/16. When I have a power, same base, and I'm multiplying, that means I'm going to add the exponent. So this will be y to the 8/9 plus 3/4. When I add these, I'm going to end up getting y to the 59/36, because I had to have a common denominator to add. If you're not good with fractions, throw them in your calculator. Next one, I have the same base w, and they have to be the same base in order to do this, and I'm dividing, so this will be w to the 7/6 minus 2/3. And when I do that, I end up with w to the 1/2 power. So that's how I simplify using the properties of exponents. It says find the square root of 81. So that square root or root, since it's square, that means 2. I can have 2. One would be the plus, one would be the minus. The square root of 81 is 9. So I'm going to write 9 plus or minus 9. So it's either positive 9 or negative 9. When I'm finding an odd root, I can only find one answer. The odd root of negative 125 or the odd cube root of negative 125 will just simply be negative 5. Now they want me to simplify. Again, I have my handy power chart here with me. You technically should think of this as separating into 4 separate problems. You're going to take the 4th root of 324, the 4th root of x to the 8th, and then the 4th root of y to the 22nd. Or I guess I could have done this too. These mean the same thing. Let's start with the 4th root of 324. When I look over here, I'm looking at the perfect force. I'm following that column. And I want to see if any of these numbers will go into 324. Well, I usually scan down. 625 is too large. I tried 256. Divide 324 by 256. That doesn't work. So then I take 324 and I divide it by 81. Well, that does work. So that's that'd be the 4th root of 81 times the 4th root of 3. Well, this 4th root of 81, as I can see, is just going to be 3. So this is 3 times the 4th root of 3. That's the first part. Boy, I'm really messy today. I'm sorry. This one I'm going to have x, and this is to the 8/4 power. It's easier for me to write it as a fraction. That will just send the 4 goes into 8 2 times, so this will just be x squared. Here I have y to the 22/4. Well, if I think of this 22/4, that ends up being 5 2/4, or 5 1/2. Let's leave 2/4. Just leave this 2/4. So now when I put all this together, what came out was a 3 x squared, and then y to the 5th. And what's left underneath the radical is going to be that 3 and then y squared. There's no x underneath the radical because the 4 went into 8 evenly with no remainder. Let's try doing another one. I'll try being a little bit neater. So here we go. So first we're gonna multiply these two, and then we're gonna simplify. In order to multiply, they have to have the same index, which they do. So this will be the cubed root, and then I'm going to multiply 2 times 4 and get 8. X squared times x and get x to the 3rd. I'm going to separate this as a cubed root of 8, and then cubed root of x to the 3rd. Going over here to my little power chart, whoopsie. Going over to my power chart, I can see that 8 is a perfect cube, so that's going to be 2. So this will be 2. And then this, think of it as x to the 3/3 power, which is just going to be 1, so we have 2x. Nothing is underneath the radical because both the coefficient and the variable were perfect cubes. Moving on to the next one. Again, I have the same index of 3. I'm going to multiply the 20 times the 18 and get 360. I am going to take x to the 8th times x squared. Remember, I'm adding exponents, so that'll be x to the 10th. And y to the 5th times y to the 8th, which, again, adding exponents will be y to the 13th. You can think of this as splitting it up into 3 separate problems. So the first thing I'm going to do is I'm going to take the cubed root of 360, the cubed root of x to the 10th, and that's a 10, and the cubed root of y to the 13th. Going to my power chart, I'm looking for my perfect cubes. So that's the 1, 8, 27 column. And I'm going to see what I can divide into 360 evenly. And I believe I can divide 27 into 360 evenly. Okay, I misspoke. So when I'm looking at my perfect cubes, I have 360. I would start with 216. That doesn't divide in. 125 doesn't divide in evenly. 64 doesn't. 27. The first one that works is 8. So when I divide 360 by 8, I get 45. So that's going to be the cubed root of 8 times the cubed root of 45. That's an 8. Then here, rewriting these as fractions, this is going to be x to the 10 thirds. This will be y to the 13 thirds. Okay, this becomes a 2. Then over here, I'm going to start my radical. So I have the cubed root of 45. 3 goes into 10 3 times, so this will be x to the third. That'll be 9, and I'll have 1 left over, so I put an x here. And just to the first power, I can write a 1 or not. 3 goes into 13 4 times, so that would be y to the 4th, which is 12. 13 minus 12 is 1, so that's y. So this is my final answer. These are times each other. They're kind of written further apart, but that's what I get. Okay, looking at the next one. It wants me to simplify. So remember again, I'm separating this as a cubed root of x to the 5th, and then the cubed root of 4. And again, I'm going to multiply by some number so that this is a perfect cube. So I'm going to worry about that first before I do anything else. So I'm going over here to my perfect cube. I want my perfect cube, and I want 4 to go into it evenly. So the first one that I see that 4 will go into is 8. So what do I have to multiply 4 by to get 8? And you're telling me the cubed root of 2, which means I'm multiplying this by the cubed root of 2. So when I do that, I'm going to have the cubed root of 8 over, and then cubed root, since they're all on the cubed root, this will be 2x to the 5th. This is just 2, and remember we did that, so it would just be a number. Cubed root of 2 I can't do anything with. X, the x is raised to the 5/3 power. 3 will go into x 1 time, so 1x can come out. And I have 2 left over, so x squared will stay underneath the radical sign. And this is my final answer. Okay, let's try the next one. I want the 4th root of 27. So I'm looking for 27 to go into a 4th root. So here's my 4th roots. And usually I look to the left of it to see if I see 27. I do see 27. And I'd have to multiply 27 by 3 to get 81. So sometimes I like to think of it like this, where I just continue this radical sign, and I multiply this by 3, and I multiply this by 3. It's the same thing as doing this, what I did down here. So I'm going to have the 4th root of 6x to the 20th over the 4th root of 81. Separating that, the 4th root of 6x to the 20th over the 4th root of 81. The 4th root of 81 is just going to be 3. Doing the numerator, the 4th root of 6 cannot be simplified. Then I have x to the 20th, 20 over 4. 4 will go into 25 times, so this will be x to the 5th. There is no remainder, so there's no variable left underneath the radical sign. And this is my final answer, and that's the 4th root of 6. Okay, moving on to the next one. I want to find the perfect 5th that 8 will go into. So again, I'm looking in the 5ths. So I'm looking here, and again, I'm going to look to the left and see where I see 8, and I see 8 here. So 8 is going to be what I have. I want it to be 32. So what do I multiply 8 by to get 32? And you're telling me 4. So again, continuing this radical sign, I'm going to multiply by 4, multiply by 4. Again, multiplying by 4 over 4, multiplying by 1. So this will be the 5th root. 4 times 3 is 12. So this is 12x to the 13th over the 5th root of 32. The 5th root of 32 is just going to be 2. And the numerator, the 5th root of 12 cannot be simplified. There are no perfect 5th roots in 12. Then I'm going to take my variable 13 x raised to 13/5 power. Again, 5 will go into 13 2 times, so this will be x squared that I can bring on the outside. When I do that, I have a remainder of 3, so this will be x to the 3rd, and that's my final answer. Okay, moving on to the next one. Use your partial list of powers chart to evaluate without a calculator. So we're supposed to be doing with this without a calculator. So what I like to do is I like to simplify this first. So I have 16 to the 2/3 power. There's two ways I can do this. One is I can think of, well, if I have the square root of 16 raised to the 3rd power, well, the square root of 16 is 4. 4 raised to the 3rd power is going to be 64. That's one way I can do it. That's easy, so let's just stick with that. The next one is I have the cubed root of 8 raised to the -2nd power. Well, the cubed root of 8 is cubed root of 8, perfect cubes, 8 is going to be 2. So this is 2 to the -2 power. That negative sign tells me that I take the reciprocal. So this is 1 over 2 squared. So this answer will be 1/4. And that'll be my final answer. The next one, I have 125 to the 4/3 power. So this is going to be the cubed root of 125. And I'm going to raise that to the 4th power. Perfect cubes, 125 is 5. So this will be 5 to the 4th. Then 5 to the 4th power is going to be 625. Again, just having my chart, don't need a calculator. The last one is I have the 4th root of 256, and I'm raising this to the 3rd power. Whoopsie, those are supposed to be parentheses. So on my chart, I look for 250 perfect fourths, 256, the perfect fourth of 4. So this ends up being 4 to the 3rd power. Going to 4 to the 3rd power, I end up with 4 to the 3rd power, I end up with 64. So 64 is my final answer. Okay, the next one is a word problem. It says the demand equation for a high-definition television set is modeled by the function P is equal to 800 minus the square root of 0.01x plus 1, where x is the number of units demanded per month and p is the price per unit. And it says, what is the price when the demand is 10,000 units per month? So I took out my calculator, I put that in my calculator, I used 10,000 for my x, and I end up with $789.95. So that's the answer. Remember, it is units. Don't forget your units. So you have $789.95. And it must be, since it's money, it must be rounded to the proper decimal place. Then it says use your calculator to approximate the demand when the price is $798. So I took out my calculator again. This time I put it into a graphing function. Let me see if I can find that. And so I'm going to have 800. And I don't think this would be smaller if I tried. Okay, so I put that function into my calculator. As you can see, I'm going to hit enter. I'm not going to see anything, but that's okay. I'm going to go to my table, so I'm going to hit Control T. I wish I could make this bigger, but don't know how. So when I do this, I'm looking for when the price is approximately $798.80. So $798.99. I'm going to keep on going until I get the price that I'm looking for. It's going to take some scrolling because it's going down really slow. And I'm going to keep on scrolling. And I'm looking for when it is $9.80. Getting closer. Right here, $798.80 would be 44 units. So then I'm going to go back here and says, so 44 units. Okay, moving on to the next one. The next ones involve transformations. So it says for each of the following graph, given function, find the parent function and graph it on your calculator, and then describe the transformations from the parent function. So right now I'm looking, and my parent function is going to be the square root of x. The transformations, I have 3 transformations on this because there are 3 things different than the square root of x. The 3 things that are different are going to be this 3 on the outside, this negative sign on the inside, and this 2 on the outside. So let's deal with them in order for the way I saw them. So the 3 is outside, so it's going to be a vertical. Vertical is what you see, so it's going to be a stretch of 3. This x is inside the parentheses with x, so I know it's going to be a reflection. So I was going to say reflect over, and that's going to reflect it over the y-axis. And then the last thing is that 2, since it's outside, is also going to be a vertical change, and it's going to move my graph up 2. Now normally this parent function would look something like this. The domain is going to be the same, but since I'm reflecting over the x-axis, my domain is going to be down here. I'm reflecting over the y-axis. I drew it wrong. My bad. Reflect over the y-axis. It should go like this. So sorry, ignore all that. So then my domain is going to be all negative numbers. So this is going to go from negative infinity to positive infinity. And my range is going to start, normally it would start at 0, because of this plus 2, it's up to. So it's going to start at 2, and I am going to include 2, so I'm going to put a bracket. And then I'm going to go to positive infinity, which is going to be a parenthesis. Okay, next time I'm graphing out my calculator. All right, the next one, I'm doing the cubed root. The parent function would be the cubed root of x. The transformations, again, I'm going to look for everything that looks different. So I have this negative sign, and I have this plus 1. So in this case, I only have 2 transformations. So let's take care of those 2 transformations. Maybe not. So the first one is this negative sign. That's going to reflect it over the x-axis. And then the plus 1, since it's inside, is going to shift it to the left to the right. It's the opposite of what I think, so it's going to move to the left 1. My domain is still going to be from negative infinity to positive infinity. And if you're not sure, go ahead and graph that whole thing on your calculator. Sorry about that. One of the joys of working at home. Okay, so the range is also going to be from negative infinity to positive infinity. Moving on to the next one, the parent function is going to be the square root of x. The transformations, again, I'm going to have 2. I'm going to have this 3 inside the parentheses, and I'm going to have this minus 1, which is outside the parentheses. So the 3 inside is inside, so it's going to be horizontal. Remember, horizontal is opposite of what you think. So that's going to be 1/3. So I'm going to say a horizontal compression of 1/3. And then this -1 outside is going to move the whole graph down 1. So my parent function is square root of x would go normally like this. It's moving down 1. So now my domain is going to be from 0 to positive infinity. That's going to be numbers that I can put in because it hasn't moved to the left or the right at all. The range, since it's going down 1, is going to be from -1 to positive infinity. Okay, looking at the last one, I have the cubed root of x will be my parent function. To find the parent function, I'm just looking at what just the variable by itself without any of the numbers. So now my transformations are going to be this 1/5 and this -4. So the 1/5 is outside of the parentheses, which makes it vertical. Vertical is what I see, so since it's less than 1, it's going to be a compression of 1/5. The -4 is inside the parentheses, so it's opposite of what I think. It's going to move it left to the right, so I'm going to say it's going to move it right, and that's going to be 4 units. My domain of a cube function is -infinity to positive infinity. My range is also going to be -infinity to positive infinity. Just a reminder, you're always using parentheses on infinity. You're never using brackets. Okay, next one, 20. The parent function is the square root of x. It is reflected across the y-axis, stretched horizontally by a factor of 2, and then translated up 3 units. So I start with the square root of x. I'm reflected across the y-axis, which means the negative sign is going to be in here with the x. I'm stretched horizontally by a factor of 2, so it's horizontal, so it's going to be inside the x, which means I need more room. And since it's stretched by its opposite of what I think, so I'm going to write a 1/2 here of x. That's the horizontal stretch of a factor of 2. And then I'm going to translate up 3 units. So on the outside, I'm going to have a +3. And that is going to be my function. Let's call it g of x, because f of x was the parent function. And that is my final answer. Moving on to number 21, you're doing the same thing. You have the cubed root of x, so I'm going to start off with the cubed root of x. I'm going to leave myself some room. Is vertically compressed by a factor of 1/4. So vertical means that's outside, which means it is what it is. I forgot this. Reflected across the x-axis, so there's going to be a negative sign there. And then translated to the left 8 units. So inside the parentheses will be the left or right movement. Since it's moving left, it's opposite to what I think, so this will be +8. So if this was f of x, I'm going to call this g of x, and that is my parent function. And this is reflecting over the x-axis, vertical compression of 1/4, translated 8 units to the left. And I believe we have one more of those. The parent function is a cubed root of x, is vertically stretched by a factor of 9. So vertical means on the outside, so I'm going to have a 9 on the outside. Translated right 5 units, so inside will be -5. And then translated down, so outside, -7. So then I am going to write this as g of x. Just be careful when you're writing this that we can clearly tell that this -7 is not underneath the radical sign. Okay, the last one, solve the equation. You're going to look for any extraneous solutions, which means that there are solutions that you come up with that don't work. In order to take care of this radical, I have to have it on one side by itself. So I need to get rid of this 5. So I'm going to divide both sides by 5. When I do that, I end up with a cubed root of 4x plus 3 is equal to 3. Now to get rid of this 3, I'm going to raise both sides to the 3rd power. So I'm going to raise that side to the 3rd power, this side to the 3rd power. When I do this, these two cancel each other, and I'm left with 4x plus 3. And then 3 to the third power is going to be 27. Then I'm going to solve this like a regular Algebra 1 equation. Subtract 3 from both sides. And I'm going to have 4x is equal to 24. Divide both sides by 4. And I get x is equal to 6. To check it, I would put this all back in my calculator in one step and do 4 times 6 plus 3 and see, put this in my calculator and see if it does equal 15. And it does equal 15. So this is my solution. X is equal to 6. Trying the next one. Again, I have to isolate the radical on one side by itself. So I'm going to, it's already isolated on one side, so I'm going to square this side, which means I have to square this side. These two, remember, just cancel each other out, and I'm left with x plus 18. Here, I'm going to take x minus 2 squared. Remember, it's x minus 2 squared, so you're taking x minus 2 times x minus 2. You are going to have a middle term, so you're going to have x squared. If I FOIL this, minus 4x plus 4. The biggest mistake is to forget that middle term. There is a middle term. Now, it's quadratic, so I'm going to set it equal to 0. I am a huge fan of keeping the lead coefficient positive, so I'm going to bring everything over to the right side. So I'm going to subtract x from both sides, and I'm going to subtract 18 from both sides. And when I do that, I get 0 is equal to x squared minus 5x, and then this will be minus 14. Then I have to product sum. So off to the side, I'm going to say my product is negative 14. My sum is negative 5. So I'm going to end up using a positive 2 and negative 7. So I'm going to rewrite this as x squared plus 2x minus 7x minus 14. So I'm going to factor out an x here. So x plus 2. Factor out negative 7. X plus 2. So I'm going to get x plus 2 times x minus 7, which means x is equal to negative 2 and x is equal to positive 7. I have two answers, so I'm going to check both of those answers. So my answers are negative 2. So I'm going to try the square root of negative 2 plus 16 and see if that is equal to negative 2 minus 2. So this will be, oh, I said 16. That's because I did it in my head. This will be the square root of 16 is equal to negative 4. Right there, you should realize you have a problem because this is a square root and it can never equal a negative number. So this one will not work, which means that that solution that I put in here, this negative 2 is extraneous, which means it's the solution, but it just doesn't work. So it's really not a solution. And then the next one is, I'm going to try 7. So I'm going to have the square root of 7 plus 18 is equal to 7 minus 2. So this is the square root of 25 is equal to 5, and 5 does equal to 5. So that is the solution. So down here, 7 is my only solution. Oh, I didn't mean to cross it out, but it's 7. Okay, looking at the next one. The next one, I have this parenthesis raised to 1/2 power. It's isolated on one side by itself. So to get rid of that fractional power, I'm going to raise it to the second power, which means I'm going to raise this to the second power. I have to do the same thing to both sides. So this will be 4x plus 5 is equal to x squared. Again, it's quadratic, so you're going to set equal to 0. Again, I like to keep my lead coefficient positive, so I'm going to take everything over to this side. So 0 is equal to x squared minus 4x minus 5. My product is negative 5. My sum is negative 4, so I'm going to use 1 and negative 5. And I'm going to have x squared plus x minus 5x minus 5, factoring on x from the first two, factoring on negative 5 from the second two, and I end up with 0 equaling x plus 1 x minus 5. So I get solutions of -1 and +5. Again, putting them in, I'm going to have 4 times -1 plus 5 is equal to -1, and this is raised to the 1/2 power. Sorry about that. So this will be 1 raised to the 1/2 power is equal to -1, which is the same thing as saying the square root of 1 is equal to -1. That's not possible. That makes this answer extraneous. EXT. Then I'm going to try 5. So I'm going to have 4 times 5 plus 5 is equal to 5. Again, this is the square root. So this will be 25 raised to the 1/2 power. It's equal to 5. So 5 does equal 5. So that one works. So my only answer is 5. Okay, the next one. I have the cubed root of x plus 5 is equal to 4. Again, I'm going to raise both sides to the 3rd power. When I do that, I get x plus 5, and then 4 raised to the 3rd power is 64. Subtract 5 from both sides, and I get 59. If I check it, if I put it in and check it, I'm going to have the cubed root of 59 plus 5. And I'm seeing if that equals 4. This is 64. So 4 is equal to 4, so it does check. Moving on to the last one. Solve the equation. Again, before I can take care of this fractional exponent, or before I can take care of the radical, it has to be on one side by itself. So this 3, I'm going to have to divide both sides by 3 so that this is isolated on one side by itself. When I do that, I have x plus 20 raised to 1/2 power is equal to -4. I'd square both sides. And when I do that, I'm going to have x plus 20 is equal to 16. So x is equal to -4. When I put that in, I'm going to have 3 times the quantity of -4 plus 20. I'm raising that to 1/2 power is equal to -12. So this is going to be 3 times 16 to the 1/2 power is equal to -12. The square root of 16 is going to be 4, so this will be 3 times 4. Whoopsie, that's a 4. It's equal to -12. And I get 12 is equal to -12. So that does not work. That means that this is extraneous. And since this is the only solution I have and it's extraneous, I'm going to say that there are no solutions. There's nothing that makes this work. Which, if I go back up here, if I have this raised to 1/2 power with the square root, there's no way it could ever equal a negative number. So moving on to the last one. Solve the equation. Again, this radical has to be on one side by itself. So this negative x has to go over to the other side, which means I'm going to add x to both sides. So I'm going to have the square root of x plus 6 is equal to x plus 4. To get rid of that radical, I'm going to square both sides. So I'm squaring this side, and I'm squaring this side. When I do this, the radical signs will cancel, so I'll end up with x plus 6. Again, this is foiling. X plus 4 times x plus 4. If you think you're going to mess it up, take the time to write it out here, and you're going to get x squared plus 8x plus 16. Quadratic, so I'm going to set equal to 0, so I'm going to subtract x from both sides, subtract 6 from both sides, and I'm going to 0 is equal to x squared plus 7x plus 10. My product is 10, because I'm product summing. My sum is 7. I'm going to end up using 2 and 5. So I'm going to say 0 is equal to x squared plus 2x plus 5x plus 10. From the first two terms, I'm factoring out an x. From the second two terms, I'm factoring out a 5. I'm left with the quantity of x plus 2 times the quantity of x plus 5. So my solutions are going to be negative 2 and negative 5. Going back to the original, I'm going to put in negative 2 first. Let's try green. So I'm putting in negative 2. So I'm going to have the square root of negative 2 plus 6 minus a negative 2 is equal to 4. Again, I can throw all this side in my calculator if I want, but this will be the square root of 4 plus 2 is equal to 4. So I get 2 plus 2, so I get 4 is equal to 4, which works. So negative 2 works. Now I'm going to try negative 5. So the square root of negative 5 plus 6 minus a negative 5 is equal to 4. So this will be the square root of 1 plus 5 is equal to 4. So this will be 1 plus 5 is equal to 4. So 6 is equal to 4. Well, that's not right. So this is extraneous. And my only solution is negative 2. Okay, I hope this helps you with the practice test, and best of luck on the test.